Good morning. Our next topic is latch. Okay. Actually, you might have noticed in the previous video I have written latches and flip flops. Okay. The way we need to study these things. We need to relate these topics and study. Okay. But actually, I didn't get time to cover all those topics. But anyways, we will start with latch today. This is just the introduction of latch, and about the structure or the design part I will explain later. Okay. So actually, what do you mean by latch? In the case of flip flop, previously we have seen that it has a stable state. We can say that a flip flop, or sorry, a latch is a non-clocked flip flop. Okay, that is, in the case of flip flop we learned the concept of the input pulse. Okay, that continuously recurring pulse, periodically recurring pulse is called a clock. You're familiar with that. So in the case of latch there will not be clock. Okay, but in order to give the output, or the how it works, the output will be completely based on the input applied to the latch. Okay, so based on the input we get the output. Okay, so in the case of it periodically checks the input and thus we get the output. Okay, so it's independent of the clock. But in the next case, in the next topic, we will be discussing about the the gated latch or the clocked flip flops. Okay, gated latch or the clocked flip flops, they are the same. Okay, in such case we learned that in the case of gated latch we will definitely have a pulse, but that is not a clock pulse. We have a pulse similar to the clock pulse, and that is called the enable signal. Okay, the details I will give you later, but for the time being let's discuss what's latch. The term latch is used for certain flip flops. Okay, non-clocked flip flops. Non-clocked flip-flops, because they are called non-clocked flip-flops because these flip-flops latch on to a 1 or a 0 immediately on receiving the input pulse called set or reset. Okay, input based on the input. They are not dependent on the clock signal for their operation. That is, a latch is a sequential device that checks the inputs continuously and changes its output accordingly at any time independent of the clock signal. So, there is no clock signal in this particular case, in the case of basic latch. In the case of gated latch, the concept will be different. I will explain later. But for the case of latch or the ordinary latch or the basic latch, there will not be clock signal. Okay. The next concept is gated latch. As I told before, a latch is actually a non-clocked flip-flop. Okay, but that is the basic case, and we have gated latch, which is actually clocked flip-flops. Gated latch or clocked flip-flops. Okay, uh, the difference is that in the case of latch, ordinary latch, the output purely depends upon the input. Okay, changes in the input, but the input was continuously checked upon. Okay, in the case of what we call gated latch or clocked flip-flops, the output depends upon not only the input but also the gating signal or the enabled input. Okay, to be frank, the gating signal can be considered as a clock. So gated latch, all these cases will be explained when we go for the design. And the thing to remember is the gated latch is a clocked flip-flop. It has an enabled input. Other than the input, the ordinary input, it also has the enable input or the gating signal. The gating signal can be considered as what we call an input, or the gating signal can be considered as a trigger or the clock pulse. Okay, and let's go for it. Okay, the gated latch or clocked flip-flops are latches which respond to the inputs and latch on to a 1 or a 0 only when they are enabled. That is, only when the input enable or the gating signal, that is the input enable or the gating signal is high. In the absence of enable or the gating signal, the latch does not respond to the changes in its inputs. Okay, we have already learned such concepts. Just try to remember in which case we did the same. Based on the input, output is obtained, but in some cases, whatever be the changes in the inputs, it will depend upon the enable. Just remember, okay? A latch may be active high. Yeah, this is the next topic. Active high and active low. Based on this, the design will also be shown later, but actually we can design latch in two cases, active high case and active low case. Okay, an active high, a latch may be of active high input latch or active low input latch. Active high means the set and the reset inputs are normally resting in the low state. Active high means some input is, one is staying in the low state, and based on the input it will get triggered to the or excited to the high state. Okay, active high means the set and reset inputs are normally resting in the low state, and one of the inputs will be triggered or will be pulsed high, resting in the low state, and it will be pulsed high whenever we want to change the latch outputs. Active low means that just the opposite. Active low means something is staying in the high level, and based on the input it will be excited to the low state, right? Active low means the set and reset inputs are normally resting in the high state, and one of them will be pulsed low whenever we want to change the latch outputs. When we go for the theory part, it can be a bit confusing, but when we go for the design, it will be clear. Okay, please go through. Now we will go directly into the next topic, that's SR latch. Okay, the name SR latch, actually it stands for set reset. Okay, if anybody asks you what is SR, it's set reset latch. Okay, set reset latch. Okay, that's a basic type of latch. Flip flop. Okay, basic kind of flip flop. Actually SR or the set reset latch, it's very simple. The operation is also very simple. Basically, we can, as I have told before, there are two kinds of construction. One is the active high case and the active low case. And here we come across the concept of cross coupling that will be explained when we go for the design. And before that, I would say that how can we construct the active high SR latch? Active high SR latch can be constructed using two cross coupled NOR gates, and active low SR latch. Active high can be constructed with NOR gates, and active low can be constructed with NAND gates. Okay, so we will go for the construction part. So first of all, let's just see what are the basic points to be remembered. The simplest type of flip flop, and two outputs labeled Q and Q bar, and two inputs labeled S and R. Okay, the state of the latch corresponds to the level of Q. Okay, that we have already learned. What will be the state of the circuit? It's based on the value of Q. Okay, state of the latch corresponds to a level of Q, high or low, that is 1 or 0, and Q bar is the complement of the state. It can be constructed using two cross coupled NAND gates or two cross coupled NOR gates. Two NOR gates means, if it's cross coupled NOR gates concept, it can be used for the construction of active high SR latch, and two NAND gates means we can construct an active low SR latch. Okay, these are the basic things that should be remembered. Okay. I have written a lot of things in the board, on the board. I will explain it one by one. Okay. This is the logic symbol for the SR latch. Here we have the S and R inputs. We have Q and Q bar outputs. Okay. So the inputs applied and we get the output. And SR is stands for set and reset, as we have already discussed. And it is also called set clear latch. Okay. That is SC latch. Can be SR latch or SC latch. Okay. We can give any name for that. Okay. That is set and clear. Here it stands for set and reset. Okay. So, as I told before, we can construct either active high SR latch or we can go for active low SR latch. Okay. First, we will discuss about the active high SR latch. Here we have, as it is active high, we go for the NOR gate, and in the case of active low, we go for the NAND gates. Okay. And this is the concept of cross coupling. I will always recommend just understand how these particular latches, the basic latch work. Okay. And basically for each case there will be 4 set and we need to understand how it works. Just understand that. Okay. Basically the use of these flip-flops will be when we go for the construction of counters, shift registers, etc. Okay. So this is the case of NOR gate. So when we see the NOR gate itself, it means it's active high SR latch. If anybody asks you how can we construct an active high SR latch, understand it's based on NOR gate. Okay. And this is the concept of cross coupling, that is we take a feedback like connection back. Here also same is the case. Okay. Similar is the case, but then gates are different here. In the case of here we use NAND gates, it's active low SR latch. Okay. And here we have 2 inputs S and R, and we have seen the set of outputs also. Then how can we get these values? I have written for each case, that is for 2 inputs means S and R 0 0 0 1 1 0 1 1 is enough, but I have repeated all these cases 0 0 1 1 1 0 1 1. Okay. So what is the purpose of that repetition? Okay. Otherwise, what are the different cases shown in this particular table? We have a set case, we have a reset case. What is Qn and what is Qn plus 1 and what is the state? Okay, I will explain to you. Qn is actually the present state. Present state means, as I told in the beginning of sequential circuits, I told that when we compare it with combination circuit where we get where we give the input and we get the output. Here it's based on memory elements. Okay, there will be a memory unit, that is we have a combination circuit plus the memory unit gives us a sequential circuit. It's clear, I think. Okay, so what we do here is, what is Qn means? Qn is the present state, that is the state in which the flip-flop is right now. The state of the flip-flop will be this Qn. And after the application of these 2 inputs S and R, we will get Qn plus 1, which means that will be the next state. Clear? I will repeat. We have S and R as the inputs. Qn is the state in which the flip-flop is already existing. Okay. So after the application of these inputs, this Qn, that is the present state, will be changed to the next state, that is Qn plus 1. Clear? Okay. And we have 0 0. So when both set values and reset values are zeros. Okay. That is, the present state can be in either 0 state. The value of Qn can be either in 0 state or it can be in 1 state. And when the inputs applied, okay, when the inputs applied to the flip-flop, that is we can say that if both the inputs are 0 zeros, okay, if the present state was 0, the next state will also be 0. That is what it is written here. Okay, I will repeat. The present state of the that state of the system means based on the Q value, the present state is 0, and after the application of S and R, set and reset, okay, the values 0 0 is applied. If the present state was in 0 state, Past tense means now it has become the past state. Okay, for the example, I am saying that if the present state is in 0 state, the next state produced will be 0 itself. Okay, and if the present state is in one state or active state, one state, value is 1. When the S and R inputs are 0 zeros, it will continue, or the next state will also be 1 itself, which means based on the input values, if both the inputs S and R are zeros, we will say that there will be no change. That is, the next state value and the present state values will be the same. Clear? We go for the next case. We have the S values as zeros and R values are 1. Okay, what is the significance of R state positive? Set means positive case, or we are going to set something. Reset means we are going to clear something. That is, the significance of SC means this is set and this is set and this is clear. Okay, clear and reset are the same, because actually what we do is we are clearing. If there is a 1 value, we clear it to 0. That is called clearing. Okay, or resetting. So when the R values are positive or are 1, when the R value is 1 and the set value is 0, that is the S value is 0, R value is 1, what we do here is, take each case. Okay, here we say that we have R value 1. R value 1 means if it was already, the present state is 0, the next state will be 0. And again 0, 1. When the reset value is still 1, if the present value is 1, it means that also should be reset to 0. If the if the value of S is 0 and the value of R is 1 and the present state is 0, there is nothing to reset, so it will be 0 itself. And when the set state is 0 and the reset state is 1 again, and the present value is 1, it means that 1 value should be reset, because here 1 is the active state, that is reset is active here, so all the values becomes 0 itself. That is reset state. Next case, set state. When the value 0 0 0 1 1 0, when the value of set is 1, and the value of reset is 0, we should understand that we need to add a value, or we need to make a value into a higher case. Okay, if the present state before the application of this particular input was 0, it should be made to set state, that is it should be made 1. And 1 0 means if the value of Qn is already, or the present state is in one state, and we apply a set state, it is already in one state, right? It's already in set state, and we need to maintain that 1 itself. Okay, the output is 1 1, so it is set state. And when both the values S and R are 1 value, S and R are 1, if the present state is 0, and if both the values are 1 and 1, if the present state is 1, the output will be into marks. That is called indeterminate or invalid. Okay, in some cases we can read not allowed condition. It's also called not allowed condition. Okay, not allowed. Or we can go for this term indeterminate or invalid. This is the case for active high SR latch using NOR gates. When we come across the active low SR latch, that is the NAND gate concept, what we need to do is, the best thing I would recommend is just write all these cases till there. These 3 boxes should be written as such. Okay, these 3 boxes, the simplest thing. Okay, these 3 boxes should be written as such. Then reverse all these cases. That is, X should come here, 1 1 should come here, 0 0 should come here and 0 1 should come here. Just reverse all these cases, we will get the corresponding values. And after that, what we need to do is reverse all these cases also, the state also. That is, first 3 boxes should be written as such, no change will be there. And after that, these 2 cases should be reversed. The best way for writing the exam. Okay. So the next thing is how we will get these values, that you need to understand, right? See, when both the cases are 0 zeros here, as its case was 1 1, when both these cases are zeros, whether the the present state is 1 0 or 1, the value remains as indeterminate. That is, it can be 1, it can be 0, it can be any values. We cannot possibly find the value. So it's called indeterminate or invalid. Okay, this is just the reverse. Okay, so it's here we have already taken into consideration the concept of active low circuit, or we have learned that enable is an active low pin. Okay, that is, when a 0 arrives there, it becomes active. You are familiar with that. So here is, as it is active low SR latch, we need a 0 in the S case to set this. Okay, so when the value of S is 0 and the value of R is 1, the present state is 1. It means it should be set to 1 value. Clear? And the value of S is 0, value of R is 1, present state is in 1 state. As this is active low case, it should be set to a 1 value when the value of S is 0. Clear? So it will be 1, that is set state. Take the reverse case. Okay, 1 0. 0 means here which is the 0 value that should be taken into consideration, that is reset. Reset is taken into consideration. Okay, reset means any value, that is, if it's 0 we should maintain it as 0, if it's 1 we should convert it into 0. That's the condition. Okay, here 0 values means for R we have 0 values. So the present state is 0, so what we do is the Qn plus 1, that is the next state, should also be 0 itself. And here R is 0 and Qn is 1, that is present state is 1, but it's active because it's active low and the reset pin is 0 and the set value is already in 1 state. We should say that this is positive case. So what we do is we need to it's a reset condition. So what we need to do is we need to convert 1 to 0, and we have 1 1 1 1. That is, when we compare the other the previous one, here when the values of both S and R are 1, we need to maintain those values that we have obtained. That is, the present state value should be prolonged to next state, and one value will also be retained as 1 in the next state. Okay, so understand what are the basic difference, and view the video again if you have any doubt. It's very clear, they have shown. Okay, please go through. Actually, there is a small, it's a mistake from my part. There is a small difference. Okay, active high SR latch. Actually, what I did is earlier I had to write here S and R, and also here also. Okay, same as the case. Actually, here we are going to construct the SR latch for active high and active low case. This is active high case. This is active low case, and the truth table that we have already constructed is the same, no issues. But in the case of figure, this R and S should be swapped. Okay, the position of R and S should be swapped. That's the only difference. And actually, in many cases, when we go for it, if it's not specified that we should go for active low or active high, most probably in many figures we have seen, we go for the NAND gate. Okay, we go for the NAND gate. Okay, I mean, we need to understand another thing is that what we need to understand is in some cases, don't get confused by hearing all these cases, but it's just for your understanding. I'm telling. Okay, in some cases, a question asked will be using NAND gate or the thing is the active low SR latch can be converted into an active high SR latch. An active low SR latch can be converted into an active high SR latch by using inverters at both the inputs. Okay, at both the inputs S and R. Okay, don't go for such cases. Don't get confused. If there is a possibility of converting an active low SR latch. That is the NAND gate concept. An active low SR latch using NAND gate to active high NAND gate SR latch. Okay, there is a possibility by including inverters, but don't get confused in all these cases. But the figure just I have drawn with the explanation with the truth table. Just remember that please swap that particular portion of S and R. Then correspondingly we get the output in the case of what we call the SR latch using active high concept. Active low, the figure is the same, but just I have redrawn that. Okay. Also, the thing to remember is when we go for the next topic, that is the gated SR latch concept. There, there may not be any specification regarding the which way you need to follow, active low or active high. So we will go for the active low case, but there is an enable pin also. So based on that and based on the inputs, don't get confused with the result or with the truth table that we derive. Okay, let's go.